Welcome back, everybody. Let's continue week 2, number 5, reverse linked lists. So this is going to be number 206. Given the head of a singly linked list, reverse the list and return the reversed list. So returning means returning the head of the reversed list, right? And here you see in example 1, it's 1, 2, 3, 4, 5, and then what's being returned is this head right here, this 5. 5, 4, 3, 2, and 1. All right, so let's think about what we have to do here. And it seems pretty straightforward. You have a 1, 2, 3, a 4, and a 5. And it seems like maybe there's two ways we can do this, right? We can maybe iterate through the linked list, put this whole thing in memory, right? Maybe put this in another linked list or an array or something. I'm just going to use an array as an example. And then in reverse, we can generate nodes, right? This could be a 5 node. It could be pointing to a 4 node. That could be pointing to a 3 node. This could be pointing to a 2 node. And that could be pointing to a 1 node. And then that 1 node would be pointing to null, right? And that works. That requires putting the entire linked list in memory, putting it into this array in the first place, and then in a backwards iteration, going from 5 to 1 and creating the linked list. And that's totally possible. It's going to take O of n memory and O of n time. Totally possible. Another approach is think about when you're looking at this linked list, how to reverse the arrows of the linked list. I want this arrow to point here, this to point here, this to point here, this to point here, and this one to actually point to something else, right? To a null. Let me go ahead and make this yellow. So this is also a strategy. Think about how to just change the arrow, right? Make it so these arrows just point in the opposite direction. Let's see if I can do it here. Just kind of pointing in the opposite direction, right? Perfect. So how are we going to do that? Let's think about it. Let's think about if we just had two of them, right? Now, when we're iterating over a linked list, this one's going to be head, and this is going to be the one that we have. And you'll think about some type of current pointer, because we're going to use pointers to iterate over a linked list. And while there's a cur, we want to advance, right? So cur equals cur dot next. And this is how we visit every node in a linked list, right? And then maybe here we can do something with cur, right? So what that's going to do is we're going to have a pointer here. This is going to be head. I'm going to make this blue here. And then, well, there's a cur dot next will be here, this 2. And the cur dot next will be here, this none, I'm going to call it. So what is this do something? Well, with this do something, we want to change the direction, right? We want this 1 to now point to here, this none, right? And then on the iteration, when we go to this 2, we want this 2 to point to this 1. We want to delete this. And on the iteration, on this none, well, by this point, there will be no none. What we do want to return is this 2 node, right? This 2 node right here is the thing that we want to return. So let's go ahead and think about what variables we're going to need to make that happen. So the code that we have here, we already have cur. We have while cur here. So when we're at this pointer, we want to set this cur, we want to set this next to something else. We want to set it to here, this none, right? And then at this 2, we want to set it to this 1. So we need some idea of a previous node, right? And the previous node can go ahead and start as none. So we want cur to be, cur.next to be set to prev. But where do we do it? we do it here? Do we do it here? Where do we do it? Well, let's say we just do it first. First thing that happens when we get to this, I'm going to switch all these arrows here. First thing that happens is I want to set the cur.next to prev, which means deleting this arrow, or it means that I'm changing this arrow to now point to here, right? You see the problem here? Now I can't advance. Now there is no cur.next. So there's no advancement here, and that's a problem. So I need to store cur.next somewhere, right? So let's say next cur equals cur.next. So I'm going to store this before I do anything else. Before I do anything else, I'm going to store a pointer to this. So this would be the first next cur. Next cur is a little confusing, so instead of calling it next cur, I'm going to call it new cur, right? So this will be the new cur later on. All right. And over here is the previous, right? And what is this head? This head is the current cur, right? So I'm saving a pointer to new cur right here. Just go ahead and color that yellow here, right? And then this arrow here, I'm going to go ahead and make that blue. Cur.next is this previous. So when that happens, I can totally advance. But cur is not cur.next. Cur is actually new cur. And this is what advancing is, right? And when I advance, I'm going to advance cur to this new cur right here. But what did I leave behind? I left behind prev, right? See, what I do want is I want these to pretty much advance together, right? I want this to advance to here, this to advance to here, and then so on and so forth. As long as the linked list exists, I want to keep advancing. And when do I stop? Well, I can stop here at cur. I can stop when cur is pointing to none. And what do I want to return? Well, this is going to be the new head. I want to return prev, right? So I want this kind of moving window of variables that are one apart. So what does that mean? That means at the end of this, I want to also change prev, right? So prev equals cur, and that has to happen before. Okay, so let's walk through one, right? So let's say none of these exist yet. I set prev as none, right? Let's walk through it. Cur is head, and I know this is the head. It's passed into it. While new cur, the new cur, so while cur, new cur is cur.next. It's here, right? Awesome. So cur.next equals prev, right? So this arrow starts this way. Cur.next equals prev means cur.next equals this, right? Prev equals cur. I move prev over. Cur equals new cur. I move this over. And then in this while loop, as long as cur exists, I'm going ahead, boom, moving new cur, and then cur.next equals prev again. So here I take this arrow, go ahead and make it blue just so it's easier to see, like that. Perfect. Prev equals cur, going here. Cur equals new cur, going here. And then the while loop, I'm back into the while loop, right? I'm back into here. So while it's cur, but actually cur is now none. So the while loop is now broken. So what do I want to return from this function? I want to return prev, right? I want to return this one. Go ahead and make that a magenta. I want to return prev here, right? Go ahead and make prev. And I will make cur green. So this is the ending state, right? So again, this is prev in the beginning, this is cur, this is new cur, and I'm moving these. They're not all moving all at once, as you've seen, but the idea is that I'm moving it, and the reason I'm moving it is like we saw before, I don't want to lose that pointer. So let's quickly look at the code and let's see if we can do this. And I'm basically going to write exactly what I have in the code, right? So prev, let me go ahead and move this so you can look at all of it at once. So prev equals none in the beginning, right? And cur equals head in the beginning. And while there is a cur, then a new cur equals cur.next. Cur.next equals prev. Prev equals cur. Cur equals new cur. And then at the end of it, I want to return prev. Now think about the edge case actually. Imagine if we are only given a single node. Well, if we're given a single node, cur would equal head, right? We'd go into here. So like, let me delete these. Okay, so prev is equal to none, first line. Cur is equal to head, second line. If there's a single node, what happens? Well, while there's cur, new cur becomes, sorry, let's make this none. New cur becomes this, none. Cur.next equals prev. And then, well, that's it, right? Cur moves over here. Sorry, prev moves over here. Then cur moves over here. And then we're returning that head. So let's try this and see how it performs. All right, in Python, in while loops, you're gonna need this colon. You don't need the parentheses. All right. Got a decent runtime. And importantly, we need to consider what we're doing with space complexity. These don't matter as much. What matters is the complexity. We're doing a linear runtime. We're doing a linear memory, because all we're doing is changing these three variables. The value of prev, the value of cur, the value of new cur, right? In this while loop, we're just changing these three variables. Now, we could have done this. We could have taken linear memory as well. Not necessary, right? Because we know that we just need to change the little pointers on the node. Now, can we do better? It seems like I'm not beating everybody with memory. You probably can do better on memory, right? We can basically traverse this while keeping a pointer to the last thing that we've seen, maybe. And it will take some clever moving around. But in general, if you can do this in linear time, this will be very helpful for you, because this is a building block for other linked list questions. Quite often you'll have to reverse or traverse a linked list in reverse order. So thanks a lot. Thanks for coming. Like and subscribe. Leave me any comments on questions you want to do outside of Grind 75 or ones that you want me to expedite, and I'll go ahead and do that. Thanks a lot.